This video is going to be on the law of sines, and we know the law of sines is the ratio of sine A over length A, sine of angle B over length B, sine of angle C over length C. This is the triangle that we defined in school, and we said that we were going to refer to the angles with capital letters: angle A, angle B, angle C, and that the opposite sides would be the length that corresponds to that angle. So if this is angle C, this is length C. This is angle A, this is length A. And if this is angle B, then this is length B. We said that there were going to be three types of triangles where we were going to be able to solve the triangle by using the law of sines. That is, when you have two angles and the immediate side, two angles and the in-between side, or two continuous sides and the immediate angle. This is the ambiguous case. And what I'm going to do is I'm going to show you an example of the first one, the second one, and the third one. Okay? This triangle right here is, the question would be solve triangle ABC. And when you look carefully at this triangle, you'll notice that they gave you an angle, another angle right next to it, and a side. So this is an angle side triangle, which would be case 1. Right? So how do you solve this triangle? The first thing that you would do is you would find the missing angle. So you're going to find this one. So you would say 180 minus 35 minus 103 is 42 degrees. So this angle right here is 42 degrees. Next, we have to find the missing length. We know this one, but we don't know A, so we have to find A. So what we're going to do is we're going to build the ratios that include A. So we're going to use this one, and we have to set it equal to either sine B over B or sine C over C. It depends. We have to know both the angle and the length. So let's look at the triangle. We know we want to solve for A. We don't know side C, so we can't use that combination. But we know angle B and we know side B. So we can use this one. So this is how you would write the ratio. You would say the sine of 42 over A. Let's look at the triangle. No, the sine of 35 over A. The sine of 35 over A, because 35 is the corresponding angle that corresponds to this length. And then we're going to set that equal to the sine of 103 over 20. And in order to solve these two proportions, what we're going to do is we're going to cross multiply. So we're going to say A times the sine of 103 equals 20 times the sine of 35. Okay, and since we're looking for A and you're multiplying it to the sine of 103, we're going to divide both sides by sine of 103. And what we're trying to do is we're trying to leave A by itself on one side. This cancels. And now we have that A equals 20 times the sine of 35 over the sine of 103. Alright, and when you plug this into the calculator, you get 11.8 for A. And you come to the triangle and you say 11.8. Alright, we still have to solve for side C. So that means we're going to say the sine of 42 over C equals, and we can still use this because we know both the angle and the sine. Yes, you can also now use sine of 35 over 11.8, but I'm just going to use the same ratio I had before. But now I want to solve for this one. So sine of 42 over C equals the sine of 103 over 20. And notice that I'm using the same ratio that I used before. Now I'm going to solve for C. And we're going to do the same thing we did before. We're going to cross multiply. So 20 times the sine of 42 equals C times the sine of 103. Okay. And this time we're looking for C. So we're going to divide both sides by sine 103. That goes away. And in your calculators, you're going to type in C is 20 times the sine of 42 over the sine of 103. And when you type it into the calculator, you get 13.7. You go to the triangle and you say C is equal to 13.7. And go and behold, your triangle is complete.